Okay, I hope that everybody had a good day, good morning off yesterday. We are going to go ahead and finish up some notes. We don't have a whole lot to do, but I do want to go ahead and get through it to make sure you have as much time as possible for your quiz, which is going to be over arithmetic and geometric series in just a few moments. So we have a focus activity first. The only big announcement, again, remember next Thursday is your what? Test. Okay, so it will cover parabolas. You got the homework today. It's due on Tuesday, so that gives you a little extra time to go ahead and get that done. And it's also going to cover binomial theorem as well. So parabolas and the binomial theorem. In fact, expect it to be really similar to what the exit ticket was as far as the binomial theorem problems go. Okay, so the first focus activity, it says a line L that is tangent to a parabola at a point P forms an isosceles triangle such that the segment from P to the focus forms one leg of the triangle and the segment along the axis of symmetry from the focus to another point on the tangent line forms the other leg. So what this is saying is that if we want to write the equation of a line tangent to a parabola, that means it only has one point of intersection. If I know the distance from that point to the focal point, I can follow that same distance along the axis of symmetry to find a second point on the tangent line. And then we can easily go ahead and write that. So let's see what this means. Write an equation for the line tangent to x equals y squared plus 3 at the point we're calling C72. All right, so there's one thing I need to do. That equation is almost in our standard form. There's just one thing I need to move. What would it be? What term would I need to move? And it's in the correct form. A 3. I'd want to subtract the 3 over. So if I subtract the 3, x minus 3 is equal to y squared. So I'm going to go ahead and put y minus 0 squared. Okay. So that's the correct form. We only have a positive 1 in front of the squared group. We got a non-squared group. In fact, we can tell the vertex now is what? 3, 0. Okay. We take the opposite of those values. And we know because y is squared with a positive 4p, it opens to the right. So let's see here. We have 1, 2, 3. So that would be the vertex. 4, 5, 6, 7. Okay, so 7, 2, there's the point C. So we're going to have a parabola that looks like this. Okay. Well, according to the information above, we need the focal point. Okay. Well, we can tell from the equation that 4p is equal to 1, so I know p equals what? 1/4. So just for the sake of making things go a little quicker, I like to work with fractions, but we'll just go ahead and do the decimals today. Okay, make it a little easier. So the focal point would be right about here. Okay. The distance between a vertex and a focal point is p, so I know here it's only 0.25 units, so they're very, very close. So if the vertex is at 3, 0, and I want to move right 0.25 units, well, what would the coordinate of the focal point be? Would I add that to the 3 or the 0? The 3, because I'm moving horizontally. So that would be 3.25, 0. Okay. So now that I know that coordinate, I'm looking for the distance between those 2 points. Okay. Between 7, 2 and the focal point we just found. Well, does anybody remember the distance formula? This goes back a couple of years. Remember, it was the big radical. Distance equals the square root of what? x2 minus x1 squared plus y2 minus y1 squared. Okay. Now I want to find the distance between the point C and the point F that we just found. Okay. Well, I'm just going to go ahead and start plugging in some values here. The difference of the x's, well, that would be 7 minus 3.25 squared plus, well, the difference of the y's, 2 minus 0 is 2, and then I'd square that, so what do I get? 4. So I'm just going to go ahead and put 4 there instead of writing out the value. Okay, so somebody help me. If we plug that in the calculator, what distance am I going to get from the focal point to point C? 4.25. Okay, thanks, Susie. All right, so I know this distance here is 4.25 units. So what the information at the top is telling me, if I now travel 4.25 units along the axis of symmetry, okay, so this is 4.25 as well, where I stop, that's going to be a point on the tangent line that I want. Okay, so we're moving from the focal point, but this time we're going left. So I'm going to do what? If I move right, I added. Left, I'm going to subtract it. So what is a 3.25 minus 4.25? That's negative 1. So this point we end up at is negative 1, 0. See, I know negative 1, 0 is on that tangent line that contains the 0.72 that we want. Is everybody okay with how we got the negative 1, 0? Okay. The two distances are the congruent sides of the triangle, and then the base is your tangent line. Well, from here, it just becomes a good old-fashioned algebra problem. We have 2 points, and we want to write the equation of the line. So what's the most important thing to a line? Slope. So we need the change in y over the change in x. You know, y2 minus y1 over x2 minus x1. So let's see here. Let's take the difference of the y. So 2 minus 0 will give me 2 over 7 minus negative 1. Or somebody say it, that's 8. But we're getting 1/4, so that's 0.25 again. Okay, thank you. Listen. All right. Now, we have 2 points and a slope. I want my answer in slope-intercept, y equals mx plus b. So I would probably start with point slope and then just rearrange it. Do you guys remember the general form for point slope? Okay. Does this look familiar? Y minus y1 equals m times x minus x1. We have our point x1, y1, and our slope m. Does that look familiar? Probably been a while. Okay. But what point do we want to use? And it does not matter. Negative 1, 0 or 7, 2. Jasmine, what do you think? What point would you like? Negative 1, 0 or 7, 2? 7, 2. So I'm going to use the point 7, 2 with this slope. Okay. So y minus y1 would be y minus 2. Okay, because I'm subtracting the y value, equals the slope m, 0.25, times x minus x1, x minus 7. Okay, so we just want to go ahead and manipulate this a little bit. We want it in slope-intercept form. Myself a little more room here. So y minus 2 should equal, somebody help me distribute. That would definitely be a 0.25x, but minus what? 1.75. And now the last step would be to go ahead and add the 2 over. So what is a negative 1.75 plus 2? There we go. So y equals 0.25x plus 0.25. Or 1/4 x plus 1/4. That should be the equation of the line tangent to our parabola at 7, 2. Okay. Did anybody happen to have that done before we began? No? Okay. All right, we'll go ahead and put that to the side. That is our first focus activity. I've only got one more thing to take care of. Excuse me. Oh, actually, yeah, let's do this. So I did say the other day, oops, probably erase those, that I wanted to go ahead and work one more problem where we rewrote a general form into the standard form, but this time we had a leading coefficient other than 1. Okay, kind of show you that it's still very similar here. All right, so this is not in your notes, but if you want to go ahead and you'll copy it someplace, because I will tell you I did put a problem like this on your test next week. Okay, so we do need to be familiar with completing the square. All right. Well, somebody tell me from the other day, what 2 terms do we need if we're going to complete the square? Well, we definitely need a 1 in front of it, but the terms themselves. 1 starts with a Q. Quadratic. Okay. We need the quadratic, the squared term, and we need a linear term. Okay, just the single x. So we have an x squared and x. Now, any term that I'm not going to complete the square with, I would move it to the opposite side. So let's get rid of that 8y. So negative 8y minus 34 is equal to 2x squared plus 20x. Okay. Now, we're not quite ready to complete the square yet. Jack is absolutely right. You can't complete the square until it is a 1x squared. That leading coefficient has to be a positive 1. Now, with parabolas, you actually have a choice. You could divide that term out, every term divided by 2, but since we're going to be going into circles, ellipses, and hyperbolas, we're going to want to practice a different way. Instead of dividing it out, let's factor it out. So negative 8y minus 34 plus some number equals, if I pull the 2 out, pretend he's a GCF, what do I have left? X squared plus 10x. There we go. See, now that I have a positive 1x squared, I have the right value to complete the square with. Okay. In fact, how do I do that? Yeah, take the linear coefficient, you divide by 2, and then you square that. And what's that going to give me? 25. So if I add 25 to the right, I'm going to add 50 to the left. Okay, why did I do that? There you go. Remember, the equation has to maintain its balance. See, I'm not adding 25. I'm adding 2 times 25. So since we're going to be pulling that coefficient out, you have to multiply your value by that coefficient before placing it on the other side. Jack? You could have. You could have. But what we're going to be looking at in the coming weeks, in fact, next week, is you're going to have something like 4x squared plus, I don't know, 10x minus 3y squared plus 7y minus 20 equals 0. See, you're going to have to complete the square twice in the same problem. Well, in order to get rid of this one, I'd have to divide by 4, but that's not going to get rid of this one. So see, that's why we're going to have to factor them out. Okay. All right. So that's a good question, but that's exactly why we're doing it. Okay, well, let's simplify the left side. What's a negative 34 plus 50? 16 equals. Now remember, this right here, that's what we call a perfect square trinomial now. If I were to factor it, the 2 group factors will be identical. So you could factor it and write it condensed, or I like to go ahead and just write it as a squared group. Whatever the sign of your linear coefficient is, because 10 is positive, I got to put a plus there. What's the square root of x squared? X, square root of 25? 5. Now we're close. We're very close to having our standard form. There's just 2 things wrong with this. We got to get rid of the 2. Remember, nothing but a positive 1 can be in front of the squared group. And what's the other problem? See, we have a squared group, but we don't have a non-squared group. Okay? Because right now, it's not appropriate for me to go ahead and say, even if I go ahead and divide by 2 and get the 8, the vertex isn't at negative 5, negative 8. Okay. And it really doesn't matter which one we do first. Would you like me to divide or pull the negative 8 out? Savion, what do you like? Divide. Okay. So let's divide everything by 2. So that's a negative 4y plus 8 is equal to your x plus 5 squared. So now let's pull that negative 4 out. This is what I was talking about a moment ago. Okay, I know this is not correct to say the vertex is at negative 5, negative 8. So I got to pull that negative 4 out, which would leave me y what? Minus 2 is equal to x plus 5 squared. And there's the correct form of my parabola. Okay, now here, I would want to do exactly what we were doing earlier in the week. I want to find the vertex, the direction it opens. I want to find the directrix and the focal point. So 4 things. Okay. So let's see here. Raphael, what direction does it open? Oh, no, could you do that? Could you stand up and do that? Just so everybody can see you? Oh, no, that's not what you did. No, you went kind of like, yeah, you did like a robot. That's cool. Okay, I like that. That's cool. Cool. Fortunately, all I got here, can't show the folks what you're at home what you're doing, but he did some pretty sick dance moves. Now, in this case, sick means good. That's y'all still say that. It's on fleek. There you go. It is opening down. Yes. Okay. What? Anyways. Okay. Let's see here, Jacob. What's the vertex, sir? What's that, sir? I'm sorry, Alex was talking. I couldn't. You're very close. Remember, we always got to put the X first, but there's something I have to do with those numbers. We take the starts with the O. The opposite. So I would actually put a -5. That's supposed to be a 5. And then +2. Okay. All right. In fact, what is P in this case? It's just 1. Remember, the negative just tells me the direction it opens. So I'm going to say that 4P is equal to 4. Okay, we always set 4P equal to my coefficient, so P equals 1. So I know the focal point would be right here, and the distance between a vertex and a focal point, in this case, is 1. It's always P units. So if I were to take -5, 2, and I want to move down 1 point, okay, Erica, what location would you say I'd be at? Now, let's think about this. If I'm moving down, would I affect the -5 or 2? The 2, would I add or subtract? Okay, -5, 1. So the focal point would be at -5, 1. Now, I also want the equation of the directrix, so I would have to go 1 unit up. Now, remember, the directrix is an equation, so it would be y equals what? Y equals 3. There we go. Okay. And there you go. Make sense? Anybody have any questions? Okay. Now, I know what you're thinking. That's all well and good. But, Mr. West, I'd love another problem to practice. Well, I hear you. Okay, here's another problem. But you'll notice, what did I do? I already gave you the answers. Okay, so sometime this weekend, I would say take 2 or 3 minutes, and that's all it should take. Practice rewriting this by completing the square. If you get those answers, perfect. Okay, means you're going to be probably in good shape for that test. If you're not getting the correct answers, come on in, let me help you. Okay. All right. Unless anybody has any questions, that is actually all I have for today. Okay, so I'll leave that up so you can finish copying it. In fact, I'll even go one step further and tell you that the problem I put on the test, it starts with a fractional coefficient. Okay, now to give you a little bit of practice on that, on Tuesday, we're going to take 15 minutes in class, and I've got a problem where you'll rewrite it starting with a fractional coefficient. Okay, get a little practice on that in addition to your test. Okay, well, you may or may not have heard, you are going to be allowed to use your notes on this quiz. All right, you are going to need a calculator, most likely. Okay, Ford, if you will turn on that light for me, sir. Let me go ahead and pass this out. Now, hang on to it. There will be a bonus at the end. This is over arithmetic and geometric series. Okay. And then there's just a few things I want to go ahead and tell you about the quiz once everybody has their copy. I'll just let you guys do your thing. Okay. All right, so let me stop this recording very quickly.